All right, this is derivatives day 2, and we're going to take the ideas we were doing in the previous lesson, which was finding slope and plugging things in, and kind of expand on that today to find actual derivatives and difference quotients. So we kind of start off with talking about the basic parabola equation again, and we want to determine the slope at two different places. So we're going to give it a sketch real quick, and we kind of pick x squared because it's a graph that you're very familiar with. So at 1, 1, we're going to have a point at 2, 4, and then at 3, 9. And just kind of connecting those, you're just looking at half of a parabola, which is, we're just looking at the positive half, kind of keeping it simple here. The first one says determine the slope at point 1, 1. So right there's my point 1, 1. This is where you're going to take a sheet of paper again. Here's my straight edge. And I'm going to attempt to draw a line that just barely touches that dot and touches the function one time. I don't want to go through the graph. I just kind of want to skim it, just barely touching that dot and then the graph. So kind of sketching that right there. That looks to be about my tangent line, my line that's touching at one place. And then I just have to estimate the slope. It's a little trickier on this one because I don't have grid lines to go by like you had on the worksheet. I'm just going to estimate it a little bit. Going from that point, kind of looks like I might be up 2 over 1 to get to that next one. So we'll say my slope is 2 over 1. Next one says find the slope between x equals 1 and x equals 3. This is a little easier because I get two x values, which means I can also find the y values that go with them. So if I plugged in a 1, I would have 1, and if I plugged in a 3, I would get 9. So now I can do slope old school. I can do y minus y and then x minus x. So 9 minus 1 and then 3 minus 1. So ending up with 8 over 2, which is 4. So a lot simpler to do it when I have 2 points to go with, which is what we're going to talk about in a second. If I were to draw a line between those 2 points from 1 to 3, draw that line, that would be called a secant line because it is connecting 2 different points on the curve. So instead of eyeballing slopes, which is what we're usually doing because we're using a tangent line and we're kind of teeter-tottering our straight edge to find the slope, we could connect, or we could use the secant line through 2 points. Here's a curve, and given it 2 points, we'll put one right there and one over there. The first point is right here, and since I don't know how far over that is, I got to use an x. I don't know if it's over 3 or 10 or 100. And then the y value that goes with it would be f of x. So if I have a 5, I'd plug in a 5 and figure out what my y is. So just using notation there. So the first point is x f of x, which is truly just an x and a y value, x and a y. The second point has to move over. It can't be at the same place. And that over space that we move is h. I don't know why we picked that variable, but that's the one. So we say it's moved over h, whether that's moved over 5 or 1 or 3,000. And so this point is x plus h, however far that is, which makes our y value f of x plus h. So now this is looking a little familiar to what we were doing yesterday when we were using that f of x plus h minus f of x formula. And that makes this point at x plus h, f of x plus h. Again, still just an x and a y value, how far over, how far up. And now we're going to do the slope of that line containing those 2 points. So the slope of this line right here. And our slope formula says we do y minus y, so y2 minus y1 over x2 minus x1. And on the bottom, my x's will cancel. I have one positive and one negative, and so I end up with this formula, which we're very familiar with. We were using it yesterday in our homework. And this is called the difference quotient. Which is really just a fancy word for slope. That is all we just did. Y minus y, x minus x. We found slope. So let's use it in an example so you can see how you would use this difference quotient. So it says using that same parabola, because it's nice and familiar to us, we're going to find the slope between 2 and 3, or the slope of the secant line between the 2 points. And we're going to do it 2 different ways. We're going to use the old-fashioned slope formula, and then we're going to use our difference quotient so that you can see the difference. Slope formula would say y minus y over x minus x. So we just need to get some y values real quick. My x's are 3 and 2. So my y values would be 3 squared and 2 squared. So I'd end up with 5 over 1. That's my slope. And that's pretty old school. I mean, you know how to do that. Slope formula is not new to us. The new part is going to be the difference quotient. So we're going to do this, f of x plus h minus f of x all over h. So taking my function, x squared, I'm going to take x plus h and plug it in to x squared. So x plus h squared minus the function, which is x squared, over h. Doing a little foiling because x plus h squared is really x plus h, x plus h. We'll come back over here, kind of continue that. Now I'm going to do some foiling. So I've got x squared plus 2xh plus h squared minus x squared. On the top I've got a couple of, oops, that's a squared, a couple of x squareds that are going to cancel. So I end up with 2xh plus h squared. And every term has an h in common, which means I can take one h out of everything. So I'm going to get rid of that one, and that one. So I'm left with 2x plus h. And then you're like, wait a minute, you just told me we're going to do two different methods and we're going to get the same answer for both. And this one gave me a 5, and this one gave me 2x plus h. What I just created using the difference quotient is an equation for slope between any 2 points. So what that means is if you give me any 2 points, any two x values, I can tell you the slope between them, and I don't need to find the y's to do it. So I'm going to prove it to you. I got 2x plus h, so 2 times an x plus an h. Our x values are 2 and 3. You can pick either one. I'm going to start with 2. The h, which we talked about up here, the h is the amount of space from one x value to the next. So the amount of space from 2 to 3 is a 1. 2 times 2 plus 1 is 5, so same slope. If you were to have picked the 3 instead, the distance, the h, from 3 to 2, going backwards on the number line, is -1, which still gets you a 5. So no matter which two numbers you give me, I'll be able to give you slope. Why in the world would we ever do this? Because slope between 2 points isn't all we can do. That just tells us the average slope between those 2 points, and our goal is to be able to find the slope of a curve at one point, going back to tangent lines. So just drawing 3 curves quick. I think you already have this on your notes. The whole concept is that here I have 2 points that are separated, which we just talked about, and I can find the slope between them, and that is finding the slope of the secant line, which can be helpful, but it's still just an average. So what I'm trying to do is slide those 2 points so they're close together so that I'm almost 1 point so I can find the slope. So here I slid the points a little bit closer together. Instead of them being spread out, I slid them just a little bit closer together. But I still have a secant line. I'm still finding the average slope until I get to this one. I have decreased the amount of space. From here to here is an h. From here to here is h. I keep decreasing it. I keep squishing it down until there's no space at all, until there is no h. H has effectively become 0, and now we're talking about a tangent line. Using that idea of h becoming 0 is talking about a limit. We are approaching, or we're wondering what would happen as h approaches 0. As the size or the space between one x to another becomes increasingly small, so tiny you can't even tell, what will the value be? So to summarize, there's a lot of vocab words that go along with the ideas we just talked about. This left-hand box is going to talk about our secant line and everything to do with that. This right-hand box is going to talk about the tangent line and everything to do with that. Most of the homework you're going to see has a lot to do with you just figuring out which box the term is in so that you know which formula to use. So this one would be called slope of a secant line. This one in turn would be called slope of a tangent line. This would be the slope between 2 points. This would be slope at 1 point. This is the average rate of change. Rate of change is really just slope. This is called the instantaneous rate of change. This one's called average velocity. and this one is called instantaneous velocity. And that's a lot of vocab. We got a couple more. This one is called the difference quotient. We talked about that on the front, finding the slope. This one is called the derivative. There are a couple of notation things that go along with a derivative. You could have y prime, that also means derivative. You could have dy dx, that also means derivative. Or something like an f prime of x, that would also mean derivative. So those are just kind of notational pieces. The difference quotient looks like this. We just did it on the front. It is our slope formula, y minus y over x minus x. The derivative, the only difference from there to there, is we've squished the h down, which means we had a limit as h approached to 0 of our slope. And I'll show you what that means as we do a problem here at the bottom. So this first example says, using 3x squared plus 4x, answer the following. They want to know the average rate of change. Average rate of change is a left box item. Slope of the tangent line, that's a right box. Difference quotient, that's left. And the derivative, that's right. In order to start any of this out, you have to kind of have a formula to work with. And the formula we are doing is slope every single time. The only difference is the box on the left, once we get our difference quotient, will have h's in it. It has a space between the two values. This one, when you get down to this guy, you are eliminating h. You're making h so small that you can't even see it. So this box has no h's. So let's do our difference quotient. We're going to have 3x plus h squared plus 4x plus h. I'm doing this right here, which is technically the same in both boxes. This one just eliminates the h. So f of x plus h minus the function 3x squared plus 4x all over h. Continuing, we're going to distribute, well, we're going to FOIL out here first. Then we'll distribute the 4 and distribute the negative. One more distribute, we're going to put that 3 in there. And then we're going to look and see what stuff cancels. You might want to make a note for yourself that at this stage, when everything is FOILed out, simplified, there's no parentheses left, everything without an h should cancel. So 3x squared had better have a negative 3x squared somewhere in the line. A 4x had better have a match somewhere else to cancel it out. Anything that doesn't have an h should go. So we have 6xh plus 3h squared plus 4h. All over h. Now they've all got h in common, so I can take an h out of each, and I'm left with 6x plus 3h plus 4. So just like on the front of our notes page here, we wanted this formula so that we could start to plug in x values, and then we could plug in the h, which is the space from one to the other. So number one says average rate of change between 3 and 5. Average rate is a left box item, which means I need to use the formula with h's, which kind of makes sense because I have two numbers and I need two variables to plug into. So I'm going to pick my x value of 3. So 6 times 3 plus 3 times, and then your h value is the amount of space from one x to the other. And our first x is 3. Our second one is 5, so the amount of space is 2 plus 4. So 6 plus 4 is 10, plus 18 is 28. Next up, slope of the tangent line. Tangent line is a right box item, which means I need to get rid of the h's. Using the exact same formula, I don't need to do this again. I just need to eliminate the h's. So I'm looking at 6x plus 4, which leaves me one variable, which is kind of convenient because I only have one number to plug in. So 6 times 4 plus 4, again, happens to be 28. Coincidence. Next it says the difference quotient. That's left box, means I need this answer, means I need to have h's. They didn't give me any numbers, which means I don't give any numbers back, I just give the formula. Next up is the derivative, which is in the right box, which means I don't have any h's, so I got to just cover them up. I didn't get any numbers, so that means I'm not plugging anything in. All I'm going to do is write the formula down. So your entire worksheet today, your process, is to first find your difference quotient, do your job on the formula, and then it's just deciding, are you in the left box, the right box, are you going to use the h's, or are you not going to use the h's?